Welcome to Study Loop.
So now we're going to work on problem 33 from chapter 5. In this problem, we're asked to give the Lewis structure for each of the given molecules. In part A, we're given N2H2. So nitrogen will give a total of 10 valence electrons, 2 from hydrogen, for a total of 12 valence electrons for the molecule. So we want to have hydrogen on the outside because it's only going to form one bond. So we put them on each nitrogen as opposed to 1 on 2, or 2 on 1. And so this takes up 6 electrons. The hydrogen atoms are satisfied because they have 2 electrons. So if we assign the rest of the 6 electrons, we see that we run out of electrons because we can't give an octet to the second nitrogen. So instead of having 2 lone pairs on the first nitrogen, we will have a double bond between the nitrogen. In this way, each nitrogen has the 8 electrons around its center. So in part B, we're given a similar molecule. We have N2H4. Here we're going to have 2 more valence electrons from the additional hydrogen atoms. So nitrogens are still central, but this time we have 2 hydrogen atoms with each nitrogen. So all this bonding here takes up 10 electrons. So we have 4 electrons left to assign, so we assign them to the nitrogen, and we see that each nitrogen now has 8 electrons around its atom, and so this is a stable Lewis structure. In part C, we're given the molecule C2H2. This will be 8 electrons from carbon, 2 from hydrogen, for a total of 10 valence electrons. So we draw the carbons centrally with the hydrogens on the ends. This gives us a total of 6 electrons already assigned, so we have 4 left. So we could put them both on 1 carbon, and that would satisfy the octet rule for the first carbon, but not the second one is woefully deficient. So we need 4 electrons also on the carbon, so that means we're going to need to share both pairs of hydrogens. So instead of having 2 lone pairs on 1 carbon or 1 lone pair on each carbon, we're going to have a triple bond. And now we see that there are 8 electrons around each carbon atom. In part D, we're given, again, a similar molecule, C2H4. This time we have 2 more electrons, 12. So we again connect the carbons, and then we connect them with hydrogen, 4 hydrogens, 2 for each carbon. Now, with this bonding here, we've assigned 10 electrons. Each carbon has 6 electrons, so we can't assign the electrons to one or the other, so it has to be shared between them, and there's a formation of a double bond.